All right, now we're going to do another type of variable force problem, which is when we take a liquid and we pump it out of a container. So we're starting here with a circular cylinder container, and we're pumping water out of this circular cylindrical tank. And we're being told it has a radius of 5, so I'll go ahead and draw that in, radius of 5 here. And it has a height of 10, and these are in feet, so 5 feet, 10 feet. And we're pumping up to a level that is 4 feet above the tank. So we've got water in here that's coming out, and it's going up here to this point that is 4 feet above the tank. And there's probably some pipe that's taking it somewhere that's 4 feet above the tank. Now they're telling us that water has a weight or a density of 62.5 pounds over cubic feet. So we're going to go a little bit slowly through this problem. First of all, if we have, we're going to slice up the water into thin slabs, and each slab will basically be, one cutout here. So it'll be a circular slab, and they want to know the volume of that circular disc. So basically, to get volume, you need area times height. So the area is pi r squared, which is 25 pi, and then we'll call the height dh for the small little difference in height. Then they want to know how much force is used to move the slab. And if you recall, force equals, or I should say mass equals volume times density. And we got that a couple pages back or a couple videos back. We said that density equals mass over volume. So therefore mass equals density times volume. So we're going to have to get mass first because they gave us density. So mass equals density, which is 62.5 pounds per cubic feet. That's density, and we're multiplying by volume, which is 25 pi dh. And by the way, since area here was square feet and change in height will be feet, this is a cubic feet situation. And just to show you the units work, the feet cubed over the feet cubed, our mass is going to end up in pounds, and we end up with here 1562.5 pi times dh. Okay, so that is just the mass. Now, in terms of, since by the way, this is in, I should say this is pounds, in the US system, mass and force are the same thing because we don't have to worry about gravity. Pounds already have gravity in them. So then they ask us, well, how far does each slab of water have to move? Well, the one at the very bottom down here has to go the 10 feet of the cylinder plus the extra 4 feet. And then say the one at the very top here just has to go the 4 feet. So basically, each slab has to move 14 minus h, where h is the height of that slab of water. Okay, and remember that 14 comes from a 10-foot cylinder plus moving 4 feet above the cylinder. So that is effectively the distance, and the integral that we need for work is going to be, if you recall, force times distance, and in this case we have 1562.5 pi as our force, and then 14 minus y as our, excuse me, I'm using h, so I should go back and put h in. So 14 minus h as our variable distance, and then of course we have a dh. And the limits of integration come from the very bottom of the tank to the very top of the tank. So you'll be taking out water from the bottom to the top, so 0 to 10. And then you can go ahead and integrate here. You're going to have 1562.5 pi, and then 14 integrates to 14y, 14h. Confusing myself with my variables, so 14h minus h squared over 2, and from 0 to 10, which gives me 1562.5 pi, and then 10 times 14 is 140, 10 times 10 is 100, divided by 2 is 50, So I need 1562.5 pi times this difference, which is 90, and I'm getting my final answer of 140,625 pi, and my work is going to be in foot-pounds.